Hello students, it's me Rizwan here. In this video, we're going to learn about special integrals. Now, you must have learned about composition of functions, isn't it? Now, let us say, let's consider a function x squared plus 1 the whole cube. Okay, I can say that this is the composition of two functions. The one function is x squared plus 1 and the other function is, I'll write, and the other function is x cube. Okay, the composition of these two functions will give me x squared plus 1 the whole cube. So if I take, for example, sine of 4x minus 1. Now this is the composition of two functions. One function is sine x and the other function is, let's say, put a comma, the other function is 4x minus 1. Similarly, if I take, let's say, 1 by x squared plus 3. Now it is a composition of two functions. One function is x squared plus 3 and the other function is 1 by x. Okay. Now, in this particular video, we're going to deal with problems, the functions, where one of the function has to be a linear function. For example, like this. Okay. So, let me give an example. Let's say 2x minus 1 the whole cube. Now here, this is the composition of two functions. One function is 2x minus 1 and the other function is x cube. So here, this is the composition of two polynomial functions. So let me take another example. So let's say sine 4x. In this case, it's a combination of two functions. One is 4x, the other function is sine x. So this is the composition of a polynomial function, a linear function and a circular function. So let me consider 1 by, let's say, 5 minus 4x. So this is a combination of 5 minus 4x, which is a linear function, and 1 by x, which is a reciprocal function. So let me take another example. Let's say e power 2x plus 5. Now this is a combination of a linear function, which is 2x plus 5, and the exponential function e power x. Okay. So in all these four functions, one common aspect is the linear function. Okay. Now in this video, we're going to learn how to find if these are the integrands. If these are the integrands, then how do we find the integrals? So let us see. So let us consider this problem. Now you can see this is a combination of a linear function, that is 2x plus 3, a linear function, and a polynomial function, which is x cube. Of course, 2x plus 3 is also a polynomial function. Now how do we integrate this? Very simple. So I'm going to consider this as, let's say, for example, you take that, okay, this is like x cube dx. Okay, if it is x cube dx, what will be the answer? The answer will be x power 4 by 4 plus c, isn't it? So same way, for this integral, the answer will be, now here x is nothing but 2x plus 3. So 2x plus 3 raised to 4 by 4, okay, plus c. But again, this is 2x plus 3, isn't it? Not just x. So look at the coefficient of x, which is actually 2. So here in the denominator, you have to write 2. So the answer is 2x plus 3 raised to 4 by 8 plus c. Now you may ask me, like, why did I write 2 in the denominator? Why not in the numerator? Okay, and why did I write 2? Okay, that's very simple. If we actually differentiate this function, that is 2x plus 3 whole power 4 by 8, then you will get this function, students, 2x plus 3 the whole cube. So let me check. If I differentiate this, so I'll get 4 times 2x plus 3. Okay, it is already here. 4 times 2x plus 3 the whole cube multiplied by 2. So you can cancel, the 2 and 4 will become 8. So finally you'll get 2x plus 3 the whole cube. Okay, you can see that if I differentiate this function, this one, then I'm getting this function. So obviously it means if I integrate this function, then the answer is this. Okay. Or you can also mention that the property is so if you see here, if integral of f of x dx is f of x plus c, then the integral of f of ax plus b is nothing but capital F of ax plus b by a plus c. Okay, so that is the answer. This is actually a property. So let us look at another problem. Okay, let us consider this problem. Integral of 7 minus 3x raised to 8 dx. Now here again we have a combination of a linear function which is 7 minus 3x and a polynomial function which is x power 8. Okay, so I am going to consider this as, let's say I have x power 8 dx. So how do you integrate it? The answer is x power 9 by 9 plus c, isn't it? So the integral of the given function is, now this is, I consider this as capital X, isn't it? So x power 9 by 9. But this is, so I will get the answer of 7 minus 3x power 9 by 9. But again, this is not x, isn't it? It's a linear function. So here the coefficient of x is minus 3. So I'll multiply by minus 3 in the denominator plus c. So the final answer is minus 1 by 27, 7 minus 3x raised to 9 plus c. Okay, so let us look at another problem. Okay, let us consider this problem, square root of 3x plus 2 dx. So here again I have two functions. One is a linear function 3x plus 2 and the other function is root x. Okay, so I'm going to consider this function as, let's say I have root of x dx. So I know that the integral of root x is 2 by 3 x power 3 by 2 plus c. So hence the actual integral will be 2 by 3 x, which is 3x plus 2 power 3 by 2. Now here, since it is not x, it is actually 3x plus 2, I will write the coefficient of x, which is 3, in the denominator plus c. So the final answer is 2 by 9, 3x plus 2 raised to 3 by 2 plus c. Okay, I hope you understood. Now one important point, students. For example, if it is, let's say, x squared plus 3 whole power 10 dx, for example. Okay, you shouldn't write this as x squared plus 3 whole raised to 11 by 11 and then in the denominator write the derivative of 2x squared, which is actually 2x plus c. This is incorrect. Okay, so you can, this special integral, you can use this method only if you have a linear function. Now in this case there are two functions. One is x squared plus 3 and the other one is x power 10. So you can see that both the functions are not linear. So to use this method, definitely one function has to be a linear function. Let's look at another problem. Okay, so let's look at this problem, 1 by 5x plus 1 whole cube dx. So I can write this as integral of 5x plus 1 raised to minus 3 dx. Again, it's a combination of two functions. One function is 5x plus 1 and the other function is x power minus 3. Okay, so here again I'm going to consider this as, I'm going to take this as x. So it looks like it is x power minus 3 dx. So this is nothing but the integral is x power minus 2 by minus 2 plus c. Hence the answer for the actual problem is x is nothing but 5x plus 1. So 5x plus 1 raised to minus 2 divided by minus 2 into, I will multiply the coefficient of x, which is 5 plus c. So this is the answer for this particular problem. Let us look at one more problem. Integral of 1 by 3x minus 1 dx. Okay, in this case, it's a combination of a linear function, that is 3x minus 1, and the reciprocal function 1 by x. So I'm going to consider this as, let us say, capital X. So I have integral 1 by x dx. So we know that integral of 1 by x is nothing but ln x plus c. So hence the actual answer is ln, instead of x I'll write 3x minus 1, but I will divide this by the quotient of x, which is 3 plus c. Okay, so this is the answer. Let us look at another problem. Let us say 1 by 1 minus 4x dx. Again here, one function is 1 minus 4x, which is linear, and the function is 1 by x, which is reciprocal. So I'm going to consider this as capital X. So I can write this as 1 by x dx, which is nothing but ln x plus c. So hence the answer is ln, instead of x I will write 1 minus 4x, but I'll divide this function by coefficient of x, which is minus 4 plus c. So this is the answer for the given problem. So now let us look at a combination of let's say a circular function and a linear function. So let us say integral of sine of 2x minus 3 dx. Here it's a combination of 2x minus 3, which is linear, and sine x. Okay, so I'm going to take this as capital X. So it looks like I have sine x dx. So we know that the integral of sine x is nothing but minus cos x plus c. Hence the answer is minus cos, instead of x I'll write 2x minus 3, but I'll divide this expression, this function, by coefficient of x, which is 2 plus c. Okay, so let us look at another problem, which is a composition of a circular function and a linear function. So let us say integral of cos x by 2 dx. Okay, so here the two functions are x by 2, which is linear, and cos x. So I'm going to take this function as capital X. So I have integral cos x dx, which is nothing but sine x plus c. So hence the answer for the actual problem is sine, instead of x I'll replace it with x by 2, divided by, I have to divide this function by the quotient of x, which is nothing but half, plus c. Hence the final answer is 2 times sine x by 2 plus c. Okay, so one final problem involving the circular function and a linear function. So let us say integral of sine of 1 minus 2x dx. So here I have 1 minus 2x, which is linear, and sine x, which is a circular function, circular trigonometric function. So here I'm going to take this as capital X. So I have sine x dx, which is nothing but minus cos x plus c. Hence the answer is minus cos of x is nothing but 1 minus 2x divided by the quotient of x, which is minus 2 plus c. Okay, so finally let us see a combination of an exponential function and a linear function. So let us say integral of e power 4x plus 1 dx. Now this is the combination of 4x plus 1 and e power x. So I'm going to take this linear function as capital X. So it looks like I have e power capital X dx. We know that the integral of e power x is nothing but e power x plus c. Hence the answer is e power. I'll replace x with 4x plus 1, but I'll divide this expression, this function, by the quotient of x, which is 4 plus c. So this is the answer for the problem. So one final problem. With this we'll wind off. So let us consider square root of e power x dx, which is nothing but integral of e power x by 2 dx. Okay, now it's a combination of two functions. One function is x by 2, which is linear, and the other function is e power x. So I'm going to take this as capital X. So the given problem can be written as e power x dx, which is nothing but e power x plus c. Hence the answer is e power, instead of x I'll write x by 2 by, but I'll divide this function by the quotient of x, which is half plus c. So the final answer is 2 e power x by 2 plus c. Okay, so I hope you learned from this video, students. Thanks a lot for watching this.